Please start the session, sir.
Right. So please confirm me, my screen is visible?
Yes, sir.
Okay, that's great. Okay, hi everyone, very good afternoon. So what we had seen till now, let me give a quick review that what I had covered. There's so many things you must have learned in these 4 days. That's for sure. So many topics were there, but what I had covered up, what we had, that let me give you a quick brief. We had started with the data science part and understood what is the importance of data science in the very first thing. Second, we had understood the concept of machine learning. Okay, in machine learning, we had seen the classification thing. Okay, how the classification can be done, and then we understood in the classification only we had gone through the part of error analysis. Okay, how we can analyze the errors or accuracy analysis. Okay, what is kind of the confusion matrix, what is ROC AUC curve. Okay, so those things we had understood in classification thing. Third, it was a regression. Okay, so we had seen the regression part. Okay, so in the regression we had seen the linear regression, as well as we had used linear regression for the prediction of certain values. Okay, and we had seen how it can be used. Okay, today we have to see the clustering. Okay, clustering is basically a unsupervised learning approach. Okay, it is a unsupervised learning approach. Here we will not have any feature, sorry, what I'm saying, here we will not have any label, right? In the clustering, in unsupervised learning, we will not have any label. Okay, without any label we have to make a model that can predict certain thing. Okay, or without any label we have to train a model. Okay, so the question is how it can be done, correct? So let's see. Okay, let's see. Suppose consider a case where you are having a features and labels. Okay, like a feature and label condition can be what? It can be like, how a things look like. Okay, we know how a things look like. Suppose I had given you some kinds of fruits. Okay, a box that is full of fruits. Okay, and I am asking you to separate the fruits into separate category. Then you know how fruits look like, or how a guava looks like, how a mango looks like, how a other fruits papaya looks like. Right? You can do it, right? That means you are having a features and you are already knowing the labels, right? So using the labels you had been trained, and based upon your training you are making the predictions and separating your whatever things that are present with you, correct? That is condition 1. Okay, condition 2, just imagine you are having the same box of fruits, but this time we are blindfolded. That means we can't see anything. Okay, nothing is visible to us. Okay, so if nothing will be visible to us, then what will we do? We will just recognize the features, isn't it? Just a minute. What we will do, we will recognize the features. Features recognize means what? We will recognize one by one. We'll just pick one fruit, isn't it? It will be like this. Just a minute. We will just pick one fruit. Okay, we will just recognize the features of it and we'll place it somewhere else. Okay, we'll place it over here. Then we pick up second fruit. Okay, then again we'll analyze the features. If the features or the shape is similar to the previous one. Okay, if the feature, because by just analyzing it, by just filling it, we can analyze the feature, isn't it? If it is similar to the previous one, we'll put it along with the previous one. If it is different from the previous one, we'll put it somewhere else. Okay, again the third fruit, again analyze the feature. If feature is similar to the previous one, we'll put it to the first one. Again the third one. Okay, so that's how, by analyzing the features one by one, what are we doing? We are training ourselves. Okay, we are training ourselves as well as we are making the clusters, correct? Correct, that means we have to train ourselves as well as we are making the clusters, right? So the same approach basically done in the clustering of unsupervised learning. Okay, that means we just have to analyze the features. Okay, and based upon the analysis of features, the similar looking features we have to put together. Okay, the similar looking features will be clustered together, and the dissimilar feature will be means separated. Okay, for example, just consider a case. Okay, suppose I'm case of Netflix, right? Netflix. Okay, now consider a case of Netflix. Now Netflix wants to recommend us certain movie or something like that. Okay, or Facebook wants to recommend us certain friends, some number of friends or something like that. Okay, or some advertisement. Okay, so these clusterings are used in so many cases. Okay, like suppose we, if we are kind of a we are on a Facebook, right? And on the Facebook we see what advertisements. Okay, so what advertisements should be shown to us, what are the advertisements should be shown to us, and what are the advertisements should not be shown to us. Okay, so the you never see an advertisement which is not related to you. Okay, on a Facebook generally we see most of the time. Okay, most of the time we only see those advertisements which are related to us. Okay, we it is very rare that we see advertisement which is not related to us. Okay, suppose you just make a search over Google. Okay, then whenever you make a search over Google, then all those kind of all those kind of product you can start, like Google will start showing you in the form of advertisement through YouTube, through normal Google search, through different websites. Okay, through all Google ads. Okay, all the Google ads will show you same kind of advertisement that you just searched, right? So basically how it happens, how it works. Okay, it somehow uses a clustering concept. Okay, it somehow uses what the clustering concept. Okay, how it uses the clustering concept, it first recognize your behavior. Okay, what are your behaviors? It can be like this. Okay, it can be our age, it can be our gender. Okay, it can be our location. Okay, it can be our interest. Okay, interest, it can be our browsing time. Okay, like browsing, because it is all over, it is working all over the world. Okay, browsing time. Okay, so it is like when are we most browsing. Okay, fifth, sixth, the search history, or you can say the browsing interest. Okay, that is already there. There can be certain different thing can also be there, like weather and all those things can also be considered. Okay, so what they do, they just analyze these features, these behavior of all the visitors. Okay, either you can say Netflix, or you can say, because in the recommendation system there are a lot many other algorithms are also used. Or not, this clustering is not only used, but clustering is one of the thing that can be used. And many you can say brand is using clustering also, right? So what happens here, they used to recognize, they used to analyze the features of their visitors. Okay, and they used to form the clusters of similar visitors. Okay, they used to form a clusters of similar visitors who are similar in their features. Okay, who are similar in their features. Okay, they used to form clusters of visitors who are similar in their features. Okay, who are similar in their features. Okay, and based upon the clusters, okay, the suppose and they used to update it daily. Okay, daily, weekly, whatever their frequency, that depends upon them. Okay, they used to update it so that you can be daily, you will be in some clusters, your clusters will get updated somehow. Okay, and these clusters will remain there for 2 to 3 days, like that. Okay, so for that duration you will see the product which is most searched in your cluster. You will see all those products. Suppose there is a product came called mobile phone. Okay, so that the ad of mobile phone will be shown to you if you had searched mobile phone in last 2 or 3 days. Okay, for next 2 or 3 days. Okay, because as of now you are in that clusters, you are in that cluster in which most of the people have searched mobile phone for buying a new mobile phone. Okay, so most of the people have searched for mobile phone. Okay, or any electronic gadget. Okay, so that's how similar features are basically analyzed, right? And clusters are made. Okay, so that's how it works. Now question is how it is possible, how it can be done. Okay, so look here, it is done. Start from the very beginning, the complete, you can say the algorithm will understand. Okay, suppose these are different things. Okay, these are different peoples. Okay, now what happened, there are 3 clusters possible, so the company must know like how many clusters are possible. They can go with 2 cluster, 3 cluster, depending upon, because there is no label. Okay, so as there are, just a minute, just give me 1 minute. Okay, so as there are no labels present, so any number of clusters they can form. Suppose they decided to form 3 clusters, correct? So how they start, they will start by defining three, you can say, three random centroids. So these are 3 random centroids, right? 3 random centroids means what? 3 different group leader or 3 different cluster leader. Okay. Now what happened? These points will put them into those clusters to whom they are nearest. Okay. For example, this first point, it is nearest to this one, this centroid one. Okay. So what it will do? It will just clump it itself with this one. Okay, the second one, as compared to all three, it is nearest to first one, so it will clump it with it. Okay, this one, it will clump it with it. Okay, the same process will happen for all of them. Okay, that means all of them will clump with some cluster, so some centroid. Okay, so for example, here it came 2, correct? For this one, just suppose it came, it was like this one, so many, all these are under this one. Okay, these all come under this one. Okay, and these 3 came under this one. Okay, so this is what that has been made. Okay, so this is the first cluster, you can say, during the process of the things, during the processing, during the, you can say, calculations, this is the first cluster formed, 3. Okay, thereafter what will happen, when these clusters will get formed, this will be removed. Okay, these centroids will be, there is no more centroids over here. Okay, there is no more centroids over here. Okay, now what happened, using the values, using the in the clusters, new centroids will come into the picture, and that new centroid will be the mean of the existing values. What? Mean of existing values. So mean of these 2 red color will be what? Will be somewhere over here. Okay, mean of this 3 blue color will be somewhere over here. Okay, and mean of these will be what? Will be somewhere over here. Right, now what happened again, when this new centroid will come into the existence, okay, these old cluster will just lose their existence. Okay, now they are not present. Okay, they are losing, they moved out from this space. Now there is no more cluster. When the new centroid came, the older cluster is not present, they just moved out. Okay, they just moved out, right? Okay, they just moved out, right? Okay, now what happened again, same approach will be done. Okay, again distance will be calculated, and the nearest twin will be configured with the the cluster. So the next, it may possible this will be the new cluster. Okay, for this it will be the new cluster, you can consider it. Just randomly I am giving, this can be the new cluster. Okay, once it is done, this centroid will lose their existence again. They will say, okay, my job is done, they will also run away. Okay, when it is done, again mean will be calculated, again we have to calculate the mean, and again new things will come into the picture. Okay, so when this time mean will be calculated, obviously the mean will be somewhere over here. Okay, somewhere over here. In this case, green is dominating, so the mean will be somewhere over here. Okay, and it will be, mean will be somewhere over here. Okay, when mean will be over here, again the older one will just, this cluster will lose their existence. Correct, they are losing. Okay, they are losing their existence, right? Now no more. Okay, now what happened again, the distances will be calculated, and now the distance, based upon the distance, new clusters will come into the picture. Okay, so when new, it may possible, it will be like this. Okay, it will be like this. Okay, and it will be like this. Okay, and after this, what happened? Again, these will lose their existence. Okay, and again, new centroid will come into the picture somewhere over here, over here, over here. But after this, if it is a stable condition, okay, and still again you are calculating the distance, no more change will happen. Okay, once it is stabilized, no more changes will happen. Okay, it will fix. Now the centroid value will not change anymore, it will be fixed. Okay, and when it is fixed, we can say that my cluster is designed and my clustering is done. Okay, and then we can give them the label, like it is been given label 0, 1 and 2. It can be given a label 2, correct? And then by analyzing the features, we can decide what this is representing, what this is representing, what this is representing. Okay, that means suppose it is a y-axis is representing your expense, y-axis is representing your expense, and it is representing your earning. Okay, so what we can say, that these guys label 1 are those people who are lower in expense and lower in earning. Okay, they are earning less, they are expending less. Okay, these guys who are in 2, they are basically high in earning but lower in expense. Okay, high in earning but lower in expense. That means some investment plan can be proposed to them. We can ask them to invest somewhere because they are earning high but expending low. So some investment plan can be proposed to them. Okay, these guys are those guys who are earning high. Okay, earning
அந்த பெட்டியில இருக்கான்னு பாரு, இல்ல இந்த லீஸ் தான் எடுத்தான், லீஸ் எங்க வச்சாங்க,
earning high and
அங்க தேடு, வேற எங்கேயோ போட்டியான்னு பாரு, எடுத்துட்டு போனியா?
so they are earning basically high. Oh god. Sir, everyone please do check your mics, right? If you had muted me, then I can't help out. I guess he muted me. He's just making his presence attendance, that's it. Okay, so basically these are the guys you can understand who are earning high but expending what less, sorry, expending also high. Okay, so credit card can be offered to them, that they can get a credit card, so that credit card, okay, so that they can make their expenses. Okay, so according to their, you can say, the cluster's nature, according to cluster nature, we can just propose any product to them. We can just make advertisement to them so that they can avail those product. Okay, so this is how clustering is basically made. Am I clear with the concept? Is it clear for you? Okay, I hope it is clear. If any doubts are there, still you can ask me, right? Okay, fine. So now next, what we have to do it, right? So let's go for the programming. Let's see how it can be done. Okay, concept wise it's okay, but programming wise, how it can be done. Just a minute. I'm just picking up a dummy data actually. Okay. Import pandas as PD. Okay. So this is a dummy data, right? Okay. So let's scatter it. Import matplotlib.py plot as plt dot scatter data x. So the x and y over here both are features. There is no label over here. Data y. Okay. There is no label over here. Both are what? Both are features, right? plt dot so. So when I plotted, what I'm getting that there are three different clusters that can be formed over here. Okay, this can be cluster one, this can be cluster two, this can be cluster three. Okay, and with the later on we can give the labels to them. Okay, so how we can give them the clusters value? Okay, that means which particular sample should be given a label 0, that we don't know. This should be given a label 0 or 1. Okay, so each sample we have to recognize that which of them should be given a label 0, which of them should be given a label 1. Okay, so that is what we have to figure out. Like it is 0, it is 0, it is 1, it is 1, it is 0, it is 1, it is 0, what it is. Okay, so that is what we have to figure out. Correct. So let's see how it can be figured out. Okay, so step first, what I told you, we have to define a centroid. How many centroids? 3 centroids, right? So what we will do, we will define a centroid and random centroids. Okay, so over here the random value can be defined like this: np dot random dot rand integer. Okay, between 2 and 20 it will give me a random integer. Okay, np is not defined, that's very nice. We have to call numpy, import numpy as np. So random value is what? 19. Each time I will execute it, I will get different random values. Okay, so what I will do, I will set the minimum and maximum. Okay, so what is minimum over here? Just see the minimum value. Okay, minimum value for x. Okay, because it is 2 feature. Okay, it is of 2 feature, right? So that's why we have to get the 2, each centroid will have 2 coordinates. Okay, because here we are having 2 features. Okay, so each centroid will have 2 coordinates, right? So data x dot minimum. Okay, it is what? 12, right? So minimum value can be 12 and maximum can be what? 72. So maximum can be over here 72. That means the centroid should be in the range of 12 to 72. Okay, in terms of x coordinate. In terms of y coordinate, so if I execute it, it can be anything, right? Okay, in terms of y coordinate, it can be maximum is 70 and minimum is what? 7, right? 7, right? So that means 2 points are defined. So what I will do, I will just put it over here. Okay, and I will put it over here. Okay, so this is going to be my first centroid. Okay, the same way I will do what? I will define this thing for the 3 times. Okay, and that will be our 3 centroids. Okay, and then what I will do, I will define these things in a dictionary. So it is my centroid 1. Okay, or centroid 0 also I can say. Okay, suppose I'm giving 0 over here. Okay, it is my centroid 0. Okay, comma, it is my centroid 1. Okay, and it is my centroid 2. Right, so 3 centroids are defined. Execute it. Okay, error because comma is missing over here. Okay, so you can see 3 centroids are defined. Okay, 3 centroids. Each centroid is having how many coordinates? 2 coordinates. Why 2 coordinates? Because your features are having 2 coordinates. It is a x coordinate and the y coordinate, isn't it? Next, just give me 1 minute. I have to adjust myself a bit. Just give me 1. Okay, so these are 3 centroids that we are getting. Each time I will execute, it will be executed and will give me 3 new centroids, right? Okay, in the same coordinate axis, correct? So okay, stretching my leg, right? Okay, next, just give it a variable name cent. is equal to this one. Okay, and execute it. Okay, execute it. Okay, so this is what I'm getting, CENT. Now I'm calling. Okay, so I got 3 centroids. Okay, now I want to see where they are lying basically. So what I can do, I can again get the plot. Okay, and I have to put it over here. Okay, and just like a scatter plot I did, I will just use the same thing for 3 more times. Okay, and it will be what, in place of data it will be sent. Okay, always it is going to be sent. Okay, sent, and then from the sent 0, that means centroid 0, centroid 0 and the 0 coordinate. Okay, centroid again 0 and the coordinate 1. Correct, sorry, 1. Correct, so it will pick 40 and 36 and plot it. Correct, the same thing will be done for the next two. Okay, so it is your centroid 0, it is your centroid 1, because from the dictionary 1, and this is your centroid 2. Here also centroid 1, and it is centroid 2. Coordinates will be 0 and 1 only. Plot it. Okay, so you can see 3 different centroids. By default, it will get 3 different colors. Okay, so these are 3 different centroids that are formed. Okay, if I again execute it, these locations will change. So whatever the location, it never matters. Any location can be used. Ultimately, it is within the coordinate system. Okay, ultimately each cluster will get at least 1 point. Okay, if each cluster is getting at least 1 point, then also it's okay. Correct. Next, we have to calculate the distance. Now, which distance formula should we use over here? Okay, you know, if there are certain points, there are 2 points over here. Okay, there are 2 points in a coordinate system. Okay, and we have to calculate the distance between these 2 points. Okay, so what we do generally, it is having a coordinate system x1 and y1. Okay, represented by x1 and y1. This is x2 and y2. Correct, and you have to calculate the distance. You know, if I have to calculate the distance, I can calculate it like this: x1 minus x2 plus y1 minus y2. But the challenge over here is, it is not a nearest distance. This distance formula is known as what? Manhattan distance formula. Manhattan distance formula. Okay, but this is not the nearest one, isn't it? Which one will be the nearest? Nearest will be this particular thing. And how this will be calculated? This will be calculated like this. If it is A, if it is B, then the distance will be what? Under root A square plus B square. Correct. Then what is A over here? A is simple over here, x1 minus x2 whole square, plus what is B over here? B is simple, y1 minus y2, isn't it? Okay, if you understood. So if I have to calculate it, what I have to do? Under root A square plus B square. Okay, what is A? A is x1 minus x2. What is B? B is y1 minus y2. So this will be the distance formula, and this distance formula represents this minimum distance between 2 existing point. Okay, minimum distance, right? So same thing will be used over here. That means from this green color, all the points will calculate their minimum distances. All the points will calculate their minimum distances. Okay, that means it will be like this. If this point needs to decide where it will go, what it will do? It will calculate the distance from it. It will calculate the distance from it, and it will calculate the distance from it. 3 distances will be calculated. So this is the nearest one. Okay, so it will go with it. Correct. So, and it will turn orange, isn't it? So this is what will happen, isn't it? But distance formula will be used. Okay, which distance formula? Euclidean. That distance formula is known as Euclidean distance formula. Okay, the nearest distance formula that I just wrote, okay, that is known as Euclidean distance formula. Okay, so that means what we can do over here? Data x, that is my x. Okay, and you have to calculate the distance. So what I can do, I can write like this: data x minus This is my data X. And what is centroid? This is my centroid. Centroid 0 from the first centroid. So this is my centroid 0. So from the X coordinate, all the X coordinate or coordinate, the X coordinate of centroid to be subtracted. So this is the X coordinate of centroid. Right. And then what I can do, I can subtract it. Better. So when you subtract it, you will get the actual figure. Okay. And then we can do what? This is what? This is your x1 minus x2. Then you know x1 minus x2 whole square needs to be done. So whole square. Much better. Okay. Same way, there will be y1 minus y2. Correct. So what is y1 minus y2? Simple. This will remain same. Data y minus centroid 0 from the first coordinate. Better. And then what I can do, I can just sum them up. Okay. And then we can calculate the root over. Okay. For the root over, it's what? To the power 1 by 2. That is, if I write over here 0.5 to the power 0.5, that is root over, isn't it? That is 1 by 2. Right. So to the power 0.5 is your root over, right? So this is the distance from the first centroid. Okay. It is what? It is the distance of all the points from which centroid? From first centroid. Right. The same way, let me repeat it again. If you any doubts, data X, correct, minus CENT cent 1 0. It is what? It is a distance in terms of X coordinate from the second centroid. Okay. And then again, data Y, it is a distance of all the Y points from the first centroid, or sorry, from the second centroid, from in terms of Y coordinate. Okay, in terms of Y coordinate. If I want a minimum distance, then what I will do, I will take the square of it and the square of the next one. Okay, and then the sum of these both. Okay, and then root over. Better. Then the same thing we can do for the third one. Okay, only thing that will change is one will be 2 and this one will be 2. Right. So all the three distances calculated. So when these three distances calculated,
அவன் கூட வந்து இவங்கிட்ட பேசுறதுக்கு பயந்துப்போம். மீன்ஸ் ஒரு லூஸ் மாதிரி பேசுவானு. ஆனா இவங்க அவனை கூப்பிட்டு என்கொயரி பண்ணி அவனுடைய எல்லா டீடைல்ஸ் தெரியும் அவங்களுக்கு. சும்மா எல்லாம் வெளியில
So can you mute everyone? Like not muted. Okay. So this is what we did, right? Now what I have to do, I have to put the distances into the data column. Okay. Data column means what? This is your data column. Okay. In this data, only 2 columns are there. I have to add more columns. So what I will do, I will add more columns like this. Data, distances from the centroid 0 or distances from the centroid 0. So data 0. Okay. And then data 1. And then data 2. Done. Okay. And thereafter data, if we call, this is what I'm getting. Okay. So that's how 3 different columns had been added with the distances. Okay. 0, 1, 2. Next, what I have to do, I have to calculate the minimum one. What is the minimum one between these 3? 16 is the minimum one, right? So that means these 2 points will go with centroid 1. minimum one in the next one, 24, 39, 0. That means these 2 points will go with cluster 0. These 2 points will go with cluster 1 minimum. These 2 points will go with cluster 0. Okay, these 2 points will go with cluster 2. That means each point is getting their clusters. Correct. So we have to compare it. Okay, that means we have to compare between these three things. Okay, so if I want to compare between these three things, that means first of all we have to extract, we have to pick these three column. Okay, then how can we pick this three column? Look, to pick this three column, what we will do, we will use LOC. LOC stands for location. Okay, data.loc bracket open bracket close colon means all the rows, each and every row, comma, which column number 0 to column number 2. Okay, so these three will be selected. Okay, it is throwing error because 0 and 2 is basically what are the strings, so give it as a quotes. Okay, we picked up these things. Correct. Now we have to compare them, minimum or maximum. Correct. So for comparing minimum or maximum, what I can do, I can use .min. Correct. So if I compare minimum, then what I will get? I am getting these things. Are you there, sir?
New Year kala eppali. Hey, first night celebration, sir.
Everyone, please mute your mic.
Hello. All the participants, please mute your mic.
31st birthday celebration. Yeah.
Okay, so what we are having, we are getting a minimum value over here, but these minimum are basically compared. You can see these minimum are compared column wise, means from each column we are getting a minimum, but that we don't want. What we want this thing. Okay, minimum between these. Okay, so this is what that means. We have to go vertically down. That means we have to use dot minimum. Okay, axis is equal to 1. By default axis is 0. Okay, so you can see it compares 1 by 1. So we are getting a minimum value. But what to do with a minimum value? There is no requirement of minimum value. Actually, the position of minimum value we have to find out. Okay, the centroid number of minimum value, the number of the who is indicating centroid. This 0, 1, 2 is indicating centroid. 0, 1, 2. Okay, so that means if you consider the data over here, which one is representing centroid? These top value are representing centroids, isn't it? So that means we have to use over here dot idx mean. Idx mean means what? ID of minimum value. Okay, axis is equal to 1. Okay, so we can see over here these are the minimum values. Correct, these are the minimum values that we are getting. Okay, ID of minimum values. Okay, so what we can do, we can just put these things into the data nearest, right? And then you can see over here what are you getting, data dot head, or the complete data. If you call, we got everything over here, right? These are comparing 0, 1, 2. It is minimum to 1, it is minimum to 0. Okay, it is minimum to again 1, it is minimum to 0, someone minimum 2, someone minimum to 0, 1, 2, like that. Okay, now we have to plot it. Okay, so before plotting, what exactly we will do, we will just assign colors to them. Okay, we will do what? We'll just assign colors to them so that it can be plotted according to our color. Okay, so how can we give the color? We can give the color like this. We will do nothing. Data nearest. Okay, nearest dot map. You can map these things. Okay, mapping can be done like 0 can be mapped with red color, right? 1 can be mapped with green color, and 2 can be mapped with blue color, correct? And then I can assign this thing as a color. Data color. Okay, and then you can see. Okay, fine. Actually, it is 0 in the quotes. It's a string, right? That's why it is showing NN. Okay, mapped R, G, and B. Now just plot it. Okay, for the plotting, I will pick these things again. Okay, I will paste it over here, right? And then when I am scattering, at the point of a scattered, I will pass over here C that represent color, that will be according to data color, according to data color column. Okay, so what will happen? The first sample will be in green color, second sample will be in red color, third sample again will be in green color, fourth sample again will be in red color. Okay, and centroid will be as it is. So it is a plot that I am getting. Okay, so this plot is showing what? This plot is showing 3 different clusters in R, G, and B. Okay, so it is showing what? That 3 centroids were, these were the 3 centroids, right? This green color is our centroid 1. Okay, we can also give it some color. Just a minute. Let's give it some color like this. Centroid 1 can be of color or just a minute. Color, right? So let me give them the different color. So because their green color is getting brown. Okay, and this can be your pink, this can be your yellow. Okay, so you can see over here now it is quite obvious, right? Now you can see this is the first centroid, this is the third centroid, sorry. Okay, yellow, centroid 3, and we had given blue color to whom? To 3. If you remember, 3 has been given at a R, G, and B. 0 had been given to whom? 0, sorry, it is centroid 0, centroid 1, and centroid 2, right? So we had given what? 0 to red, okay, 1 to green, and 2 to blue. Okay, that means there are 2 blue points. That means these must be to the centroid 3rd, okay, or centroid 3rd or centroid 2. Okay, that is C2. Okay, so that means yellow color is what? C2. You can see this is 0, 1, and 2. Okay, it is what? C2, correct? Now green, okay, these are the green persons. Okay, so green is basically connected to C1. Okay, so that's why you can see this is the cluster C1. Okay, this is C1. Okay, pink color is C1. Okay, and 0 is what? Red. Okay, so these are the red. Okay, these are connected to centroid 0, and this is your C0 in brown color, right? So you can see over here, according to the distance, the random clusters had been formed. Okay, so after forming a cluster, as I told you, these will just lose their existence. They will not be there. Okay, only these will be there. Okay, now what happened? The the mean will be calculated. Mean means what? The mean of blue color will be somewhere over here. Okay, the mean of red color will be somewhere over here. Okay, mean of green color will be somewhere over here. So obviously with this mean you can easily say that this red is going to be converted green. Okay, this red is going to be converted green because of this. There are so many blue color, some blue color, this particular centroid will obviously convert this green into blue. Okay, this some of them can also be converted. Okay, so we'll see this thing in action by defining the new centroid. Okay, so for defining the new centroid, just we have to do the data filtering, right? So data, what we can do, data nearest, okay, double equals to 0. If you compare it, what will you get? You'll get true or false. Okay, and then what you can do, data, just filter it. So it is all the value in the centroid 0 or cluster 0. Okay, now what I said, we have to calculate the mean of what? Mean of x coordinate and mean of y coordinate. Okay, so just pick the mean of x coordinate. So for mean of x coordinate, pick the x coordinate over here. This is your x coordinate, right? Mean of x coordinate of all those points which are in centroid 0 or cluster 0 dot mean. This is the new centroid value in terms of x coordinate for the first one. The same thing can be done for the second one also. Correct? It will be what? Y. Okay. Now what you can do, you can update it. CENT send. Sent what? Sent 0 and this is what? 0. Okay. And then the same thing can be done over here. Sent. Okay. Send 0 and this is 1. Right? So your first centroid is updated. Okay. The same way you can update the second centroid. And then the same way you can update the third centroid. Okay, the changes that you have to make over here will be, it will be first centroid, okay, and it will be your second centroid. Correct? Data nearest, it will be 1. It will be 1. It will be what? 2. It will be what? 2. Clear? So this is how your all the three centroids have been updated. By using the data filtering concept, we had updated all the three centroids. These are all new three centroids. Okay, so if these are your new three centroids, then what you can do, we can now pick the value like that. Okay, the same thing that we did over here. Correct? Same thing needs to be done. Okay, again from this new centroid. Okay, so again from this new centroid, calculate the distance and do the things. Okay, again from this new centroid, calculate the distance and we have to do the rest of the things. So this will be the new distances from the new centroids. Okay, and this is going to be your new things from the new centroid. Done. And then we are having data. Okay, you can see R, G, and B, all those things are there. These are basically rearranged. Okay, these are basically what? These are basically rearranged. Okay, now these are rearranged, then what I can do? Again, I will plot it. Okay, plot it. Things gets better. Still not that much. Some improvement may be there, but you can easily consider that in the next time improvement will easily can be done. Okay, so next what we'll do, again we have to do the same thing. That means again we have to do the same part, this one, centroid update. Okay, so for centroid update, execute it. Okay, this is the updated centroid. Okay, and then again distances, again color and all, data, plot. Done. Now if you see, if I will do it again, if this is the last update, now if I update the centroid, it will be updated this time. This is the last update. Okay, but nothing will change. Okay, nothing will change. You can see it will not change. I can execute it for n number of times, but it will not change. Okay, because now it is fixed. Correct? It is fixed now. Correct? You can see it is not changing, right? So that means what? That means our each value got a label, right? That means your each value got a label. Now that label you can represent in any way. Okay, you can say that is this 2 is a label, or you can say this 0 is a label. 2 is a label or B is a label. You can consider, okay, 2 is my label, or you can consider B is my label. Okay, label is of your choice only. Okay, this 0 is the label for this one. Okay, so each particular value got their labels, right? So that is how unsupervised learning clustering works, by analyzing the features. And here, for analyzing the features, what are we doing? We are considering the centroid for analyzing the features. Correct? Now to develop the algorithm, we have to do certain things. Okay, what we can do, we can basically, we can't write these things again and again. So what we can do, we can create a loop for that. Okay, or we can create a function for it. Okay, for example, there are two things happening over here, three things happening, right? First, I will tell you from the very beginning, stepwise. This is your data. Creating functions for clustering. Okay, so this is your data. Let me define it again. Right, after data, what we did, next step, we have defined the centroid. So just I'll copy this and paste it. Right, and thereafter what we did, we have defined this part. Okay, after the centroid, we have defined this part, right? This is for calculating the distances. So just define it over here. And thereafter we have defined this color and all. Right? So just copy this. And these two are running all together. So just below it we can define it, right? Now we can give a function name to it, right? DEF. What is the function name? It is assignment, right? First time you're assigning the clusters. So you can give a assignment, assign. Okay, so this is assignment function, right? Done. So it is assigned now. So once it is assigned, thereafter what we have to do, we have to update. What we have to update? We have to update the centroids, right? So for update, where is it? This is the update function. So DEF update. Right? So these are the update things. Update. Okay. So once it is done, you know what we have to do. Okay. You know what we have to do. How we did it. If you go back, you will see that first, after defining data, we defined centroid, then we executed this part. Which part? This part, for calculating the distance. This part executed first. That means assignment executed first. After the assignment, what we did, we updated. And after update, again assignment, and then again update, then again assignment, then again update. That means it is like this. First of all, assignment is executed. That means we have to call the assignment function first. Okay, assignment function, SSIGN assignment function first. Then we have to call update, and then again assignment. Correct. So my algorithm is created now. Okay, and then again update, then again assignment. That means we can put this thing into loop. For I in range 20. Okay, it will update and keep assigning the things. Correct. And then I will execute it and things will be done. That means if I will not execute, you can see how my data looks like. This is my data is looking like, because nothing has been done till now. Okay, it is my data. Okay, and as I execute it, which is my final algorithm, how many data will look like? This is my data. Everyone got there by executing this one. All my data got their label. And once it got their label, what I can do, I can plot it for the visualization purpose. Correct? So this is what that is plotted. R, G, and B. 3 different plots. Is it same? The colors can be different, the labels can be different. Okay. So in this case, these are the labels 1, 1, 1, 1. Okay. Earlier it was 2, 2, 2, 2. Okay. The first was 2, 2, 2. This time it is 1, 1. So that doesn't matter. Anything, label can be anything, right? So it is our complete algorithm created. Just let me know if anything that is not clear over here. Am I clear with it? Okay, so if it is clear, that's fine. So now we will take some kind of, I will also recommend you to use some data. Okay, we'll take a small break, then again we'll continue. But before the break, I am recommending you some data. Okay, Kaggle. From the Kaggle, you can take a data. Okay. So this is a very popular data actually. Okay, this is data of mall customers, right? So what is it? It is having customer ID, gender, age, annual income, and spending score. Okay, so we have to form a cluster of similar customers. Okay, on the ground of annual income and spending score. On the ground of annual income and spending score, you have to make a kind of a clusters of similar customers. Okay, so just figure out how many clusters can be formed and try to form those number of clusters, right? I'm sharing this data file with you as well as my own file, and just make a change and try to make it. We'll take a small break and then we'll again continue so that I can have a cup of tea. God, why it's just a minute. Okay, so let me share this thing. So this is the code file. Just access it and try to code for the data that I had shared with you. Okay, on the ground of annual income and spending score. Okay, I will take a 5 to 7 minutes of break and then I will be back.
Okay, sir. Okay, sir.
Okay. Hi everyone, am I audible now, sir? Am I audible? Am I audible? Hello? Okay. Thank you. Okay, so we'll just resume back. Just give me 1 minute. Okay, so I hope you had gone through that. Okay, so let's do the thing for some actual data. Okay, so this time I'll do a little different way, but almost the same concept in a more like less number of codes. Okay, mall customer data for clustering. Okay, so we need a data set. So just load a data. Sorry. Okay, so this is my mall data. So I will use first of all mall underscore df is equal to pd.read csv pd.read underscore csv. Okay, it is mall, right? Mall.csv mall.csv mall underscore df dot head. Okay, so this is data that I'm getting, right? Now I can use all the four features. Obviously, four of the four features can be used, but I am going to use only two features because plotting can be done. Okay, with the four features, plotting can't be done. Okay, with the four features, only mathematical analysis can be done. Right. That means suppose you are using more than one feature, more than two features, then again the plotting will be little difficult. Then what we can do? We can just suppose four clusters are formed: cluster 1, cluster 2, cluster 3, cluster 4. Okay, so what these clusters are representing, then what you can, how can you decide? Okay, you can decide like this, because with the plotting you can easily decide. But if you're not using plotting, then what you can do, you can just calculate the mean of all these values. Okay, mean of all these values. Suppose the mean of C3 is highest, then we can see that this is the highest thing. Okay, the mean of C4 is second highest. Okay, because all the means will be in descending or increasing order. Okay, by calculating the means we can decide, right? Okay, so over here what we will do, right, I will first of all separate the features that I am willing to use. Okay, suppose I am just willing to use only two features. Okay, annual income and spending score. In that case, what I will do, mol underscore df. Okay, and we can pass these values over here. Better? And this is your df, right? Okay, now in this df we are having one important thing that we can change, that is df dot columns, because columns are having so much big value, annual income and all, right? So I'll replace this thing with df dot columns is equal to okay, income I will replace with in. Okay, and spending score I will replace with sp. Okay, so now it will be better. Now df dot head. So it is insp, right? Now we have to make the, make the cluster. So for making the cluster, first of all I will plot it. So how can you plot? Plt dot scatter, okay, df in, okay, and then df sp, okay, and then plt dot show. Better? That means you can see that at least 5 clusters are possible, right? That means if you want to read this plot, what you can say, that there are the people, okay, these are the people, if this is our income and this is our expense, so these are the people who are in higher in income, okay, but less in expense. Okay, these are the moderate people, these are the people who are higher in income, okay, and higher in expense. Okay, so basically this is how we can just recognize all of them, right? We can recognize all of them, but for we have to form the clusters. For the clusters, what we have to do, we have to define the centroids. Okay, so let me define the centroids over here first of all. Okay, no, sorry. Okay, so first of all I have to define the centroid for the same purpose, right? So centroid, how many centroids? 5 centroids. Okay, so for the 5 centroid I have to just copy this thing. Okay, and I have to paste it over here. Okay, so it is what, 0 1 2, this is 3 and this is 4. Even I can use a loop also for it. Better we should use loop only. Anyway, thereafter we have to define the range. So range will be what? Range will be minimum and maximum, isn't it? So what is the minimum of in dot minimum? Minimum of in is 15, right? So all these values will be 15. Okay, and maximum is what? 137. So all these values can be 137, so that at least one, you know and then minimum of expense what I had given, SP, right? So SP, maximum of SP is what? 99. So all these values will be what? 99. Correct. And minimum is what? 1, right? So all these values will be 1. Done. Okay. So both are defined. Now what I can do, I can use this particular function, the function that I have defined over here, but I'll make a little change in this function because this function is looking little, so much lines of code are there and same lines are basically repeated. Okay. This can also be done with loop. So I'll define a loop for it. So I'll make a small change over here. So what I will do, for I in sent. Okay. For I in sent, right? So what will return for I in sent? Let's see. For I in sent. Okay. It will return the print I. It will return actually 0, 1, 2, 3, 4. Okay. And these are your these things. Okay. So for I in sent, what I can do, I can use over here data. Okay. Data and here 0, 1, 2, 3, 4 I have to use. So I can use over here data str of I, right? Str of I, because I'm passing a string value, right? So it will be data 0, data 1, data 2, or data not data. It should be df, right? Because the data is in df over here. This time I'm using df. Okay. So df, okay, this is what I can do, is equal to again df, it is in, right? In minus cent sent. Okay. Sent, it is be it will be what? 0, 1, 2, 3, 4. Again 0, 1, 2, 3, 4, right? So again it will be what? I. Okay. And again it will be what? 0. This will remain always 0 because for the first coordinate, a square of it, a square of complete value, right? So a square of complete value. Okay. Plus the same thing, I have to just copy this part and I have to paste it over here. df, it will be what? SP. SP. Okay. Sent I will remain same, it will be 1. Correct. And then root over. So automatically this loop will run for how many times? 5 times. Okay. So in that case, these 5 lines will lose their existence. There is no requirement. Correct. Now come to the next thing. Okay. So when it is done outside the loop, okay, outside of the loop, what we have to do, df nearest is equal to data dot log 0, 1, 2, 3, 4, right? 4 will be 4, 0, 1, 2, 3, 4. Okay. idx max is done. Okay. Then again df color map. So what I am mapping, df nearest, correct? RGB, 2 more color is required, right? So 2 more color can be what? It can be 3. It can be given with a color red, green, blue, and it can be given black. Okay, and then 4th can be given a brown. Better. So you can see now my number of lines of code decreased. Okay, so this will be our assignment function. Okay, now same thing we are going to do for the update function. Where is update function? This one, right? So I will just copy this whole thing. I had not plotted it. I'm not doing a stepwise. I'm directly doing it. Let me just, I want to check how my algorithm is behaving for a huge set of data. Okay. So here also for I in range, I in sent basically, right? So the value of I will be what? 0, 1, 2, 3, 4. Correct. And it is changing over here. So it will be control X, sorry, control Z, control C, control V. Okay. It is what? I. Okay. Send I 0. okay, is equal to df, either also df 0 x dot mean. X in place of x, it will be what? Income. Okay, in, correct? And then again this one, send I0 I1. This will be sent I1. That is the second centroid. This is also df. This is also df. Okay, nearest, and this is going to be sp. Okay, better. One small change here. I am comparing 0 actually, right? So 0 I can't compare, right? Because first time 0 will be compared, second time 1 will be compared, right? So here also I have to give str of I, string of I, string of I, correct? So you had compare nearest with 0, picked up in column, compared 0, picked up y column, and then rest all will be the history. Done. So this is your update function. Better. So you can see how the codes gets, this thing is done. You can comment it. Okay, so you can see this also can be used for loop actually. Can we use it within the loop? Just a minute, let me check. For I in range 5. Okay, for I in range 5, send is equal to this one. Send should be defined over here. Previously, send is equal to right. So you can define over send I is equal to control C. Okay. So let me check. I guess it should work. I'm not sure, but still but logically it should work, right? So let's see. Let me call it. Yeah, it's worked, right? 0, 1, 2, 3, 4. Okay. So this is also get decrease, right? So let me remove it. Okay. Let me remove this thing also. Okay. So you can see we have defined a loop for defining the centroid, 5 centroids. Okay. If you have to define 10 centroids, you have to just give a value over here 10. Okay. And this is your assignment function that is working over here, right? And then this is your update function, correct? And then if you have to define an algorithm, then what you can do, you can just use like this. Okay, let me define it. For I in range, okay, for I in range what? 50. Okay, I treating for 50 times. Okay, before that update will be called, sorry, assignment will be called. Okay, and over here again update will be called, and then again assignment will be called. Key error 4. Okay, assignment is having a giving me error. Key error 4. 0, 1, 2, 3, 4. What is giving me error? Just a minute. Give me error 4. Something is missing, is it? Just a minute. Okay, this kind of things happen whenever you are trying to create something. Okay, let me check over here. df. Oh, comparison is not done. Yeah. No, comparison 0, 1, 2, 3, 4 is there, right? Now what I'm doing? This is what I'm doing, right? Date df nearest. Okay, okay. Here df is not given. That's why. Okay, df I had not used. That's why it was not working, right? Now it will work. Okay. So, okay. So this is my centroid. These are the. Okay. This is not required actually, right? Leave it. So these are my centroids. Okay. These are the assignment function. This is update function. Okay. And then this is the complete algorithm. So algorithm run. Now I have to do what? I have to just call the df. So this is when df dot head. Okay, each value got their, got their things. Okay, now I have to plot it. So plt dot, I'll just copy and paste. Color can be, sorry, color can be what? df of color, right? Okay, so it is what I am getting. Okay, it's still not formed well. So what we can do, we can just execute it for some more number of times. It is not changing a bit. So what I will do, I will just try to just execute everything from the beginning. Okay, so this is my mol.csv. Okay, this is my df dot head done. Then I scattered it. Then okay, then I had created a centroids. Okay, then I have created a, just let me compare stri. Okay, 0, 1, 2, 3, 4 in minus centroid i0 square of it, and then sp minus centroid i1 square of it. So this time I will change. Okay, nearest from 0 to 4. Okay, that's fine. idx mean. Okay, color will be a basis of nearest, df of nearest dot map 0, 1, 2, 3, 4. Okay, that's better. Update I am doing sent i0 sent i1. That means the first centroid, second, okay, 0, 0, right? 0, 0, 0, and then I'm comparing with 0, 0, and then insp mean is calculated, right? That's better. And let me execute it for 200 times. Assign, update, assign. That. And let me now pick it. Now plot it. So you can see it is plotted perfectly now. Okay, actually in between some changes had been made, that's why it got affected. Okay, it is getting plotted over here. Okay, so over here there are certain things that you can see. Okay, my final algorithm is this one. We can create a complete function for that. For example, we are getting a value from, we can just ask the user that how many clusters he want to form, he want to create. Okay, so how many clusters he want to create, that's what we can ask the user, isn't it? So in that case, what we can do, we can just create something like this. Okay, like def k means, this is a k means algorithm. So k means, okay, df, we can ask the user that how many clusters you want to use. So x I can give, that means it will be called with x. Okay, and then based upon that this will be called, right? I'm putting everything in a single function. Okay, so this will be present over there. So user said for I in range x. Okay, if user will enter 5 cluster, then 5 clusters will be formed. If user entered 7 cluster, then 7 clusters will be formed. Okay, and here also you can give this that many thing. So it will be there, and thereafter assignment function. Okay, thereafter assignment function can be called. and assignment function, but again it will be here also to put so many things. Okay, there's so many changes you have to make. Anyway, leave it. Leave it as it is, otherwise so much programming will be done. Okay, so finally we can see we had formed the clusters. Okay, so these clusters are representing what RGB, all the colors. Okay, so if a person is in red color, okay, I have to just extract the information of all the persons who are basically high expense people, high earning and high expense people. Okay, or high earning and less expense people. So these are black are high earning and less expense people. Okay, and these are brown or moderate people, right? So what we can do, we can just separate it like this: DF nearest double equals 0. Okay, so these are what red color person. Okay, these are the red color person, right? So we can just use now DF. Okay, this is what we are getting, correct? This is what we are getting, right? Now it is the same thing, right? Simple thing. Now if it is more than, suppose these are all persons who are high earning and high expense as compared to data. Now just imagine if we are having a case where we can't plot, then what we can do? If that is a case where we can't plot because of higher dimension, we can directly read centroids. Okay, because centroids are ultimately what? Centroids are ultimately the means. Okay, and we can compare these centroids. Okay, so when you compare these centroids, we can easily figure out that the centroid 1 are basically, in both the case, it is a maximum. Okay, in centroid 1 it is both maximum, so we can consider this thing as a maximum, as a case where the maximum things are there. In centroid 2 both are minimum, so I can say that all those people in group 2 are basically low earning and low expense people. Okay, centroid 3, this one, this centroid 2, basically centroid 0, 1 and 2. Okay, centroid 2 is what? This one is low, this one is high. That means earning is less, expense is high. Okay, centroid 3, earning is high, expense is less. Okay, and this one is moderate. Okay, so by reading the value of centroid also we can do the same thing, and thereafter you can easily train your model, because now when you got the labels, now you can use supervised learning to train your model. Okay, when you are not having the labels, it was what? Unsupervised learning. But when you got the model, sorry, label, you can use supervised learning. Correct? This is what we can do for the clustering. Okay, so it is the concept like how clusterings are formed. Okay, that you can easily do. I have already shared the file with you. Now let me give you the most simple way of doing the clustering. Okay, so that is a clustering through library. Okay, clustering through k-means library. Okay, clustering through what? K-means library. Okay, so if I have to use clustering through k-means library, then what we have to do? We have to first need the data, right? So let me pick the data. Where is data? This one is my data, right? Just a minute. Okay, I'm updating the DF actually. Okay, this is my data. I will make it df1. Okay, df1 is equal to mol df and then df1 this one, because df is used earlier. Okay, so this is my df1, right? Now what I can do, I have to use a library, right? So how can I use a library? Look here, to use a library, it's very 2 line of code. Okay, just 2 line of code. What we have to do, we have to just use over here from, let's search out, from sklearn dot cluster import k-means. Okay, from k-means. Okay, and thereafter here you have to give what? You have to define the model name. So this define k model is equal to k-means. Okay, number of clusters, so n clusters is equal to, I have to define 5 clusters, so just n clusters equal to 5. That's it. Thereafter what we will do, k model dot fit, what I can, sorry, dot fit df1. That's it, job is done. Okay, it will and thereafter I have to know the cluster's name. Then what I can do, k model dot predict df1. Okay, it will make the predictions. So you can see the prediction 0, 1, 2, 3, 4. Okay, these got the predictions. Thereafter what I can do, I can store this predicted value in some like predicted label. So PL can be predicted label, I stored over here. Okay, and same process that I used over here for what, for giving the colors, the same process I can use over here. Okay, I'll just copy this thing for assigning the colors. Okay, but before using it, PL is my this one, I will assign this thing to your df1. Okay, labels are predicted. These labels will be equal to what, this will be equal to PL, right? So it got the label. Okay, and thereafter what you can do here, I can just pass the labels. Okay, so df color, df labels dot map, and all those things are done. Or df1 it should be, right? Df1. Okay, so now you can see df1. What is df1? Now df1 is having all the things. Okay, it is not giving us the color because I guess it is 0 only. There is no string value. Okay, so you can see over here, dot fit df1, ये चीज हो गई, like this is done, and thereafter df1 you can see got the color. Okay, labels also, colors also. Okay, now if you plot just like earlier, you'll get the thing. So how many lines of code required? Just 3 lines: import, fit, and predict. Okay, and when you predict, you got the labels, right? Now you have to plot it. So what you can do the concept that we had used earlier, just to verify is it working same or differently. So simple, pick it and plot it. Okay, so it will be what, df1, everywhere it will have to pass df1, here also df1, and here also df1. Okay, period also. Correct, so almost same. Correct, so when we created our algorithm, it was also giving the same cluster. Here also I'm giving the same cluster, right? Now here we are having some less number of data. One important question is also there, okay, that we need to answer. Okay, what is that? The question over here is, how do we come to know that how many clusters we have to form? Okay, this is fine. Okay, this is fine. That means through plotting we can know. Okay, that okay, we plotted initially and we figured out 5 clusters are formed, and we formed 5 clusters. What if we are having 10 features? Okay, what if you are having 7 features? Okay, so 10 features and 7 features can't be plotted, isn't it? So in those cases where we can't plot, how can we decide how many clusters to be formed? Correct. So in k-means clustering, there is a rule. The rule is known as knee rule. What? The rule is known as knee rule, and many people also call this thing as a elbow rule. Okay, so you can call it elbow rule or knee rule. Okay, the rule will not change, right? Rule will remain same. So what is knee rule or elbow rule? It is like this. Suppose these are our distribution, right? Just a minute. So these are our suppose distributions. Okay, so how can you figure out what is the most balanced situation? Okay, what is the most preferable situation for the plotting? How can you decide? Okay, look here, what exactly happens in the knee rule? We just use hit and trial. Hit and trial means what? First of all, we decide that I have to form a single cluster. So for single cluster, there will be a single centroid. Okay, then what we do, we calculate the distance of all these points, average distance of all these points, okay, from that particular single centroid, and we store that thing as loss 1. Loss 1 is equal to, suppose, some distance calculated like some x1, okay, or d1. Okay, then what we do, we decide that no, I have to form 2 centroid, okay, or 2 cluster. Okay, then we decided no, 1 cluster is not enough, so I have to form 2 cluster. So when you decide you have to form two cluster, what you will do? You will define two centroids, right? When you decide, okay, when, just give me 1 minute. There is a call I am getting. Just give me 1 minute. Hello. Hello. Right. Yeah, right. Prasanna. Prasanna, I will call you just in half an hour. Just give me half an hour, right? I'm really sorry for that, right? Okay. So, what happening? As I told you, loss 1 will be calculated, then loss 2 will be calculated, then loss 3 will be calculated, then loss 4, 5, like that. It will continue, right? Now, what is loss 2? Loss 2 will be like this. That means there will be two centroids will be defined. Okay, and then because of two centroid, two clusters will be formed. Okay, then distances will be calculated like this, right? And then the average of this distance will be stored. Okay, then again three centroid, then fourth. Then obviously one thing is very obvious, just you can think of it. If you are having a single centroid, then the distances will be more, because this extreme point is also getting calculated from here. This extreme point is also getting calculated from here. Okay, but when you are having two cluster, that means two centroid, then distances will be less, isn't it? That means two cluster, that means the centroid moves more closer to the specific cluster. When you are having three, then distance will be more less. When you are having four, it will be more less. When you are having five, it will be more less. That means distance will keep decreasing. Okay, it will keep decreasing, right? So based upon these distances, okay, what exactly happened? We draw a graph. Okay, we draw a graph like this. Okay, we draw a graph like this, right? That means maximum distance, then little bit, then like this, then like this, line like that. Then what happened after some time? Okay, when the appropriate number of, you are crossing the appropriate number of cluster. Okay, suppose the maximum cluster, the more specific number of cluster is 5 cluster is good. Okay, or 4 is good, or 3 is good. What happened after this point? Knee will be formed. Okay, that means after this the distance will not change a lot, because now you are overshooting. Okay, and that knee decides that how many clusters will be formed. Okay, just see over here what we will do. First of all, let me pick the data value. Elbow rule for k-means. This is my data value, right? This can be your df2, okay, and then you can see over here df2, right? Okay, so what we can do, we can apply a k-means elbow rule. So for I in range, okay, any range you can give, suppose 14 or 15, anything I am giving, or it should start from 1 basically, it should not start from 0, right? And then k means, that is my model name, is equal to k means, okay, number of clusters is equal to I, okay, and then kms dot fit, okay, whatever fit df2, correct, and then call kms dot inertia. Okay, what is inertia? Basically inertia will give you that particular thing that I was saying. That means in case of one cluster, all the distances; in case of two clusters, all the distances; in case of three clusters, all the distances from their specific centroids, so losses dot append this one. Where is losses? Actually there is not defined losses, so just define a losses over here. Okay, losses is equal to null value, right? And then it is done. Oh, correct. Okay, that is it. Okay, right? And then what you can do, you can plot it, plt dot plot range losses. Okay, that will be on x-axis, and then on y-axis what we can do, sorry, range what, range 1 to 14, right? And on the y-axis what I can pass, I can pass losses. Okay, and then plt dot so. Okay, so what it decided, it is saying that number of clusters that you can form is 5. Okay, so this rule will always be applicable in any case. Okay, if you want to verify this rule for the first case that we did, let me verify this rule for the first one also. Okay, just a minute. Quickly, you have to just do a copy and paste. Elbow rule for dummy data. Okay, the dummy data that I defined. Okay, like for the first one. Okay, the first case, right? So let me use it, this one. Okay, so just use it. Right, data is defined, and thereafter what I have to do, we have to define this thing, losses and all. Okay, only I have to change over here data. Correct, losses dot append will be done. Okay, and you can see the plot. Okay, you can see where I'm getting the elbow. I am getting the elbow at 3. So it will give you the number of clusters to be formed in any unanswered data. Okay, and when you get the number of clusters, what you can do, you can just put that number of cluster over here, right, in that position over here, and then confirm it. Let me use one more data quickly to verify this thing. Okay, I'm having one more data set. In 2 minutes I will use it and verify this thing. Okay, downloads. This is a call center data set. It is representing like who is working good in the company and who is not working good, right? Right. So it is what employee performance. Okay. Okay. So it is what DFC for call center data is equal to pd dot read underscore CSV. Quickly I will apply over here and check it. It is what call center data dot CSV, right? So call center data dot CSV. That's it. Correct. So it is what, let me first of all look the data DFC. Okay, it is a performance matrix, experience in month and call attended a day. Okay, like how many experience and how many call attended. So it will be a good thing to explain like how person is working. Okay, so that means what, if I have to plot it, plt dot scatter. Okay, DFC, it will be what, experience in month, comma, DFC call attended. This data you can easily get over Kaggle. You have to just search and you can get the data, like the mall data and all this data, right? And then plt dot so. Okay, so it is what I'm getting. So if it is your experience in month, okay, x-axis, y-axis is call attended, that means these persons are having highest experience and they are working very hard. Correct, these persons are in less in these persons are high in experience but working very, they're not working good. Okay, they are the persons who are basically good in experience with compared to others, good in experience but they are not working good. Okay, these are the persons who are working good but experience is less, means they are new persons but still they are working good. Okay, and these are the persons who are new person but not working good. Okay, so that's how we can say. So these are the asset for the company, right? So so we are not having any label, then how can we train my model to recognize the asset? Obviously through clustering, but for the clustering we need the cluster how many, because 4 clusters are there. I want to see my elbow is defining how many cluster, because in the first case it was 5, in the second case it was 3. In this case I want to see how much, so you see DFC, right? And just see what it is defining. Okay, it is defining 4. Okay, so that's what I said. Elbow rule will, for the maximum number of times, will give you the correct number of clusters that you can form. So it is saying that number of clusters that we can form is 4, and obviously 4 clusters you can see also over here, right? So that's how we can form the 4 clusters in this particular data. It is a call center data, right? Okay, so this is it. I have already shared this thing with you. Okay, you can just access this thing, clustering unsupervised. Okay, there is one more there is one more good application of unsupervised, that is known as dimensionality reduction. That means reducing the dimensions. Okay, how can we reduce the dimension of a data set having a huge set of features? Okay, how can a huge set of features can be reduced to a less number of dimensions, right? So that dimensionality reduction we will discuss in the next class. Okay, obviously every mathematical aspect we will discuss. Okay, like how you can reduce the number of dimensions, that is going to be very important. That is also unsupervised learning thing. Okay, because in dimensionality reduction also we only consider features, we will not consider the labels. Without considering the labels, the number of features will be reduced to a lesser number of dimensions. Okay, that will be the next thing. It is done for this particular part. Is everything clear for all of you? You can access the code, right? Try with more number of features. You can try with more number of features over here using this small data, using the using the other part of it, like you are having some other things also present over here, like gender, age. Okay, so with the gender age also please do try, because I didn't use gender age, because if I use gender age the plotting can't be done. But if you try with gender and age, still you will get the 5 clusters. Okay, so just please do try and check if anything changed you are getting. If more than 5 clusters or less than 5 clusters you are getting, so you can just ask me, we will also discuss. Okay, try with gender and age and then figure out how many clusters are possible. Okay, this is what I'm expecting from you. Okay, but you have to again map the gender into 0 and 1. Okay, you can try with age as well. Okay, let me try with age also. Let me use over here. Use this thing, right? Okay, if I'm using age, then what will happen? Okay, age, right? That's fine. Like with the age also I am getting it is at around 5 or 6. So both you can choose. By applying the age part, it can be 5 or 6, right? It can also be 5 or 6, right? Where the things are formed. Okay, for better angle what we can do, we can decrease the number of to 10. Yeah, 5 can be used or 6 can be used with the age. Okay, so you can try with 5 or you can use with 6. Okay, so in this clustering thing, there is no fix how many clusters you want to form. You can form any number of clusters, but you have to figure out the optimum value. Okay, so optimum value, this particular thing, your elbow rule basically tells you the optimum value. So that's it. That is it from my side. If you want to ask anything, you can ask. Otherwise, we can just sign off. Sir, are you there?
Yes, sir. Yes, sir.
Venkat sir. Okay.
Any participant will have any query, please ask. No problem. I hope, sir, you check the chat box. No problem.
Yeah, I'm checking it. Chat box I'm checking. There is no such query as of now.
Yeah. Okay, then no problem. Thank you very much, sir. Bipul sir, you have given nice session about this unsupervised learning in clustering. Thank you very much, sir.
Thanks a lot, sir. Take care, everyone.
Yeah. All the participants, please fill the attendance. Okay, as if you have not filled the attendance, queries come after practice. Okay. Ajay Patankar is saying queries are coming after practice. Okay, no problem, Ajay. Thank you very much.
Yeah, right.
Sir,
Yeah.
hello.
Yeah.
Sir, the data that we use is trained data or not? The database that we use, mall data or other data.
No, these are just raw data. Someone has uploaded those data on the Kaggle. Kaggle is having around 65,000 plus data sets. Okay, so people used to upload their data over there, and some competitions run. So we just pick the data from there.
Okay, so the data is not trained.
No. Data we don't train. It is the model that we train using the data.
Okay.
Yeah, right.
Uh,
That is just the raw data that we are picking from the Kaggle. That's it. Any source we can use for the data picking.
okay. But in some where the trained data is available, if we use Google for searching any kind of data, there is the data that is already trained. Some specific data.
Okay. So can you just if you can give me some link so that I can explain that thing in a better way. Like if you are having that kind of data that you are saying that a trained data, like, so I can easily explain for that. If you can give me a link for that.
Okay, sir.
Right.
Tomorrow.
Right.
Okay,
So because without looking at that, but I can't explain, right?
Okay, sir. Thank you.
Thank you. Thanks a lot, sir.
Okay. Thank you, Vipul.
Right.
Dear participants, actually on Saturday we are taking a valedictory function. So in that valedictory function, some AICT representative or IST representative may be present. So in front of them, I would like to invite you for giving the feedback. So if you have interest, please send me your name on my WhatsApp. No problem. So please, if you come forward for giving feedback, it will be very better for that. Okay. So please forward me your names. I will write your name and we will announce. Please send your name along with your college name. So we will introduce yourself as well as we will invite you for giving the feedbacks. Okay. Thank you then. No problem. Okay. We will meet tomorrow in 10:25 sharp. Okay. Yeah.